Welcome back to part 2 of our series where we are basically incorporating the streaming API functionality into our TD Ameritrade Python API library, right? So in our previous video, we basically just set the stage for everything. We talked a little bit about kind of what we were trying to do, what the end goal is, and basically how we want the streamer client to function. Then we started going through the process of taking our main client library, so there's just the regular TD API one, adding in some functionality that would make a request to our get user principals endpoint, get some information back, send that information to our new client object, which we're now calling the TD streamer client. And basically at that point, we just defined an initialization method that would take that information and just do a couple things. Things like, hey, we're just going to add the user principal data, or we're just going to define our WebSocket, something like that. Nothing too fancy, but basically it's just kind of setting the stage. So now what we're going to do is we're going to take today's video to do what I would call is the core of it. So we're going to start doing a lot of the functionality related to logging in, sending a request, receiving those messages, and so on and so on. This is definitely where things are going to get a little bit more complex. And also, just as a reminder, it is technically still a work in process, so do not be surprised if the code that you are currently seeing on this particular video changes from when you potentially go on GitHub, because there is a very good likelihood, in fact, I can guarantee you basically 100% that this code will change as time goes on. So with that being said, let's get back into it. All right. So first thing we're going to do is we are going to define a private method. So private methods in Python, technically nothing is private in Python. So we use basically notation to define what our private methods are. So if it usually has a leading underscore, that is something that is considered private and that the main user should not be using. So this is going to be a private method, which basically is building our login request. Now, because this method is part of the client object itself, I want to make sure I'm passing through my self keyword. This way I can access this method throughout my class object. Now, once we've done that, what is this method supposed to do? Well, remember how in that previous series a long time ago, every time we had to build a request, we had to use this like complicated like dictionary thing, and it was really always a pain because, the problem was it was really easy to have format issues and all sorts of different things. So basically what I'm doing is there's a couple methods that will help automate that process and make sure where you don't have to build it. You just have to pass in some predefined information and I will build it on your behalf. So one of those methods is the build login request. Now, just to save some time, what I'm going to do is I'm actually going to just copy some pre-built code that I already have. Where is it? I think I have it on GitHub. There it is. Here, perfect. And so all it is a dictionary, right? So all we're doing is we are taking a dictionary and basically defining some of its keys and values and associating certain values to that particular login request. So at this point, you can see it's nothing fancy. It's just a dictionary. And inside that dictionary, we have a request key that basically holds a list of requests. Now, the request normally follow this type of pattern, which is you define the service that you want to basically get from the server. In this case, we're doing an admin service. Every request will usually have a request ID. So this is a unique identifier. So that way, as data is streaming back to us, we can say, hey, that data that you're seeing right now, you see that request ID, that's 0. We know that that data is associated with this particular request, which is our login request. So this, while not necessarily super important, obviously though, if you're streaming multiple different services, this is a great way to identify what data I'm looking at and where it might potentially need to go in my script. Additionally, most services will have a command, and that command will vary depending on what type of service you use. So the admin one is actually kind of special because there's a login command, there's a log out command, and so on and so on. Now, what this will do is basically say we're going to log in to our streaming service. Additionally, we need to basically provide some information about the type of account that we have and our app ID, because this is used to identify what services we have access to, because I will tell you right now, there are services that some of you do not have access to, myself included. And then the source is basically like our app ID, so that way they know, okay, well, this developer is using this particular service. And then also with our parameters key, we basically pass through any parameters that we want to. Normally it's keys and fields, but for the login request, we want to pass through our credentials. So basically that big old dictionary we talked about in the last video. And then on top of that, we also want to pass through our token. So this is our streamer token, and that's also used in our account activity, and the version of the API that we want to use. Now, at this point, I do want to talk about one other thing because I actually need some people's help. So this is going to be changing a little bit because for certain accounts, you might not have certain services enabled. And so I'm going to have to somehow build in some logic that will look at the information related to your account and determine whether I should be using one account versus another account. So for example, in some accounts, you might have access to futures in Forex. Well, if that's the case, then that means you probably can use certain streaming services. Now, I am in the process of testing some stuff, and so I would like some help if possible. Where is it? Perfect, here it is. So ignore this for right now. But down here, so under my experimental section, there are 3 streaming services that I am currently trying to test. Now, from what I can tell, I think they're working. The problem is I do not have the ability to trade futures and Forex on my account. And so what I'm believing is because I do not have those services enabled on my account, I am not able to stream level 2 quotes, because these ones I know for sure I can stream. I've tested them. These ones, however, I do not seem to be able to stream. Additionally, there are some endpoints that supposedly seem to be associated with the NYSE and then the Opera. And so, or is it Oprah? I think it's Oprah. I don't know. OPRA, whatever it is. Those ones also seem to have streaming endpoints, but you actually have to have a subscription to that service. So if you don't, then obviously you can't use that level 2 service. I'm thinking these ones tend to be those particular services. So if you don't have the ability to trade that, they're not going to give you these streaming capabilities from the API perspective. So even though you might be able to see it on TD Ameritrade's Thinkorswim platform, you might not be able to access it on the platform. So if somebody could test this out for me who has access, that would be phenomenal. And if you could actually just send me basically like the little data that's sent back, it would be phenomenally helpful. These symbols should work because futures options, I tested that one with level 1 and I did get a response back. So that was good. And then with this one, they seem to all be working the same. So again, if somebody could try that out for me, be super, super helpful. Okay, but back to TD. Okay, so now basically all we're doing is we're defining our login request, right? So once we have our login request, we do want to return back a proper formatted request. Now, every time we send a request to the server, it needs to be in a JSON string format. So we're going to be using the JSON library, and we're going to be calling the dumps method. So S at the end means string, otherwise it means a file. We're going to say take this string and basically convert it to a JSON object notation string. So this way, when we make our request to our server, it won't freak out and say like, hey, you're trying to, request something that you can't, right? So that's our login request. From this point, we're going to actually build our main streaming request. Now, the main streaming request is leveraging a couple other methods that we're going to define below. But for right now, let's just basically build the skeleton. And then what we'll do is we'll define the other methods that go along with it. So with this one, it's still a regular function, and it's going to be self. And then what we're going to do is we're going to first grab the login info. So that's usually our first step, is just build a login request. And that means use the self keyword, build login request. It's a method, so we need our little curved brackets. Additionally, we will have data request. Well, I'm assuming we have data request. This is probably some functionality. Again, I might have to build into it, which is just because you log in doesn't necessarily mean you have any data request. So there might have to be some additional validation at this point where I say, hey, let me check to make sure that you actually have the request necessary. So we'll create a new variable. We'll call it data request, and this will equal JSON dumps, and then our data request. And then it's an S at the end. And then technically what I could do, just to be a little bit more consistent, why don't I just wrap this one inside that function as well. So this is a nice way to just make it a little bit more consistent. And then also the data request is actually one of our attributes of our particular client object. So I want to make sure I use that self keyword. So we've defined our login request. So this basically says, hey, we want to start streaming. The data request, well, that's going to be all the services that you want to stream data for. What else do we have to do? Well, now we're starting to get into what I would call the more complicated stuff. Now, if you remember my previous series, one of the libraries that we used was async.io. Now, I used to call it asyncio, but people got mad at me, so I'm not going to call it that. It's okay. But basically, async.io is a way where we can run certain Python functionality concurrently. So that basically just means that we can run it at the same time. And there's obviously advantages to this, because that way, what we can have happen is we can basically call multiple requests at the same time and have that information sent back to us in the order in which we receive it. So basically, if we receive multiple requests at once, then it can handle those types of requests all at once. Now, how we do this is we basically define something called coroutines. And so those coroutines are basically just more generalized subroutines that basically do different things, right? So they could just be a function, right? So they could just be a function that says, hey, print hello world, or, hey, go to this website, grab all that data, whatever you want to call it. But the idea is that we're going to basically define all these coroutines, and then we're going to basically create tasks that represent those coroutines. And we're going to say, hey, we're going to submit all of our tasks to our event loop. And that event loop is basically going to run all those tasks, and it's going to wait for them to finish. Now, this is something I am still heavily working on. I actually was able to gracefully close our streaming session. It's very early stages, so I just was able to basically close it. But now I'm going to start trying to build in logic where you can specify, hey, maybe I just want my stream to close at like 4 p.m., right? So maybe like when certain events happen, I want my stream to close on its own. So right now there is functionality to close it gracefully, but I am still basically incorporating it. So do not be surprised, again, if that changes tremendously compared to what you might see today. So again, back to async.io, everything that we're going to be submitting is basically on this thing called a loop, right? And so that event loop is basically where we're submitting all of our tasks that we want to have performed. And what we're going to be doing is running those concurrently, so basically together. So the first thing that we need to do is start a loop. Now, if we do self.loop, because I am planning to use this loop at different points inside my client object, I'm going to call asyncio. Oh, I said it. I'm sorry. Get event loop. Now, there's a couple other options here. I'm reading a little bit more onto the documentation right now. There is one that is called get running loop, which basically, from what I understand, is supposed to just get the current one that is running, so the main one that we're on when we start our program. Supposedly, if I was reading it correctly, this one might actually default to the running loop if it's already there. So I have to do a little bit more reading on that, but for right now, I'm just kind of keeping it the same as my old code until I kind of get a more for sure answer like, okay, this is definitely how we do it. Okay, so once we have that loop, we're going to start a connection to our WebSocket, right? So start connection to WebSocket. Now, we're going to actually have our own separate method for that, but it's going to return back our connection object. And we're going to say self loop run until complete. What this means is it will run this task. It basically will keep running until that particular task is completed. So the idea behind it is once it is complete, it will actually close that loop for us in a certain regard, right? Well, it won't necessarily, I think it actually does close it if I remember correctly, but basically once that task is finished, it will stop. Now you're going to see in a little bit, I actually do the opposite with another one. Again, I'm experimenting a little bit. So if I can do this in a different manner, I might, but for right now, I think this is probably what it's going to stay like. So this one will basically connect to our WebSocket. And then from here, what we're going to be doing is we're basically going to be defining all the type of tasks that we want to have happen. So define the task we want to have happen. Now, this is where things, again, might get a little bit more complicated, but we're going to call async IO. And then there is this ensure future method. Now, this ensure future method is basically like a broader version of a task from what I was reading. Because different things, I guess, can be futures, but with a task, like there's certain limitations. But basically the ensure future is like a broader version of a task, if I was remembering correctly. But basically all we do is we just define the things that we want to have happen, right? And so one of the things that we want to have happen is we want to be able to receive a message, right? So we want to receive a message, and we want to receive that message from our connection object. So when we connect, I want to make sure that I receive that connection message saying that, hey, we did in fact connect. Additionally, we do also ensure future self, and then we want to send a message. And then this will be our login request. So this one is saying we're connected. This one's going to log us in. And then our next one is going to basically submit our service request, right? So this is where we're going to go and actually start doing the data services. Now with this one, it's kind of fine the way it is, but right now it's just 3 different tasks. Now previously, you probably would have saw task, list, and and it was a list, right? So it looks something kind of like that. I was doing a little bit of reading, and I changed it a little bit, and I'll kind of explain in a second. So right now I'm just defining 3 separate tasks, and I'm not putting them into a list. Now, finally, after we've defined our task, we're going to basically start our loop, and we're just going to keep it open, right? So start the loop and keep it open. Because technically right here, once that task is completed, it will actually close. But with this one, what we're going to do is we're going to do self.loop, and then we're going to do run forever. And so this one will keep running until I call the loop.stop method. And so once I call stop, then this loop will stop. And we'll see later that I'm actually going to build in some logic that will go through the quote unquote closing process. Now, once we've done this, we've basically defined our main streaming function. So in your main one right here, to basically now run this one, it would look something like td stream, right? So this is just taking all that functionality, it's kind of abstracting it away, and it's saying, just use that one method and I'll do the rest for you behind the scenes. Now, right now we can't stream because there's a bunch of syntax errors because it's saying, hey, you're trying to use a message, like a method that doesn't exist. So right now we have to define what that looks like. Okay, so the first thing that we're going to do is we are now going to define one of our first asynchronous functions. That first asynchronous function is going to be called connect. And with connect, what we're going to do is going to first create a connection. Now, to define an asynchronous function, we basically are going to use the async keyword. And with that one, it allows us to use the await keyword inside of our function. Now, what this also does is it's kind of like a decorator where then async IO knows how to handle this function and understands that we can run it concurrently. Okay, so once we've done that, we're going to do self.connection equals await, and then from here, it's going to be WebSockets client.connect, and then it's going to be self.WebSocket URL. So this will create a connection to our WebSocket. Once we have that connection, it doesn't mean it's open. Well, we should assume it's open, but I'm going to do a check to make sure it's open. So check to make sure we are connected. Now, this is actually a really simple method, but all we're going to do is we're going to say if self check connection. And then what we're going to do is that particular method will just return a Boolean value. And if it is, it will return the self.connection object. So that was our first asynchronous method. So this is basically saying this is something that can run concurrently. So it can all start at the same time. Now our next one, where is it, is not an asynchronous function. This one will just be our check connection method. Now with this one, it's very simple, nothing fancy here. If self.connection.open, this will return a Boolean value. If it is open, then say connection established, streaming will begin shortly. Again, nothing crazy, just something to let you know, hey, we're all good. Otherwise, I will be raising a connection error because something's happening. Something's allowing us to not connect. It could be credentials, it could be a whole host of things, but the important thing is I obviously don't want to start streaming if I cannot connect to the streamer. So that's our check connection method. So far, so good. We're now going to define our next asynchronous method, which is going to be called send_message. With this one, we are going to use the keyword self, and then we're going to also have an argument called message. So this is the content that we want to send to that streamer. And so what we're going to do is we're going to say await self.connection send. What did I do? Connection send, and then message. So again, a very simple line of code, but it's kind of good to keep it separate. All we're doing is saying, hey, take our connection, so right now our WebSocket, and send a message to it. Make sure to wait for that message to send before continuing. That's the purpose of the wait keyword. Wait before you continue. Our next asynchronous function is going to be called receive message. With this one, again, we are going to have our connection this time. And with this one, this is again kind of where the bulk of the data transferring is happening. So we're going to start it off with a while loop. So just keep going until canceled. Again, this will probably change a little bit compared to what it is right now, but I have to do a little bit more research before we get there. So we're going to say while true, keep doing something, right? Well, the first thing I want to do is grab and decode the message. Now, what we're going to do is we are going to take our message and we're going to store it in connection.receive. Okay, so we're going to take our connection that was passed through and we're going to receive it. Now, something I'm going to try a little bit probably later down the road is I'm going to see, do we even need to pass this through? Can we just have maybe like await self.connection received? Part of me is saying yes because I'm doing it up here, but I just haven't had time to test it yet. So I don't know if it's truly going to break anything or not. But I wouldn't be surprised if this one, again, it changes a little bit. And then obviously too, I think that would probably make things a little bit easier as well. So it's kind of an interesting thing to see what happens. I think I'll probably have to keep it only because I have to pass through this. But I'll have to see maybe if I can call it after calling this one. So again, I'll have to see a little bit. But regardless, the first thing I'm going to try to do is decode that message. From here, I'm going to do a try except statement. And the reason why is because sometimes the content will not come back correctly. So message decoded equals JSON.loads message. Now, what happens sometimes is the content might not be correct. And so it will actually fail sometimes. Now, sometimes it's related to the decoding process, and then sometimes it's related to something else. Now, for the most part, our requests are going to have a key called data. So check to see if there is a key called data. Remember, when we call the .json method, it will actually convert it to a dictionary object. So what we're going to say is if we see the key data in message decoded, and then I'm going to call the keys word, then we can continue. And we're going to say the data will equal message decoded. I'm going to go data and then 0. Now, initially what I was doing was I was printing it right here. So I'd print the data. It's kind of pointless because I'm going to print it down below. So for right now, I'm actually not going to do that right here. In fact, on the main GitHub one, you're going to see that changed in a little bit. But if something goes wrong where something happens and all of a sudden we cannot get that data, that's fine. Then what we're going to do is we are going to print that data out. And then we're just going to print a line break, and we're going to say print received message from server. And it's going to be that. And then it's going to be string message decoded. Now, some might be asking, well, why are you even putting that there if you're not planning to use it? Well, some functionality I'm still trying to build in is writing all this content to like a text or CSV file. For right now, it's going to be a very basic writing to it. So I'm not going to assume that you want it in a certain column format or whatever it is. But the idea behind it is I want to first check if there was data. And if there was data, then obviously I want to write that to the CSV file. So right now this seems a little bit pointless because you're like, well, you're not using it. So why would you even have it there? The reason we're going to be using it to dump the data. Okay. Have the message equal the normal message, something like that. Okay. So what have we done so far? We've done received message. We've done, what else did we do? We did some other stuff. And, oh, I forgot my outer loop. So again, this is why I don't like this. Technically, I'm wrapping this in a bigger try except statement. And so basically this is kind of the, if something goes wrong and I have no idea necessarily what it might be, or if it's like a connection error, then here is where I'm going to be actually closing that connection. And so we're going to say except WebSockets.exceptions.connection closed, then print, say print connection with server is closed. And then do our break because we want to basically get out of this while loop. It's no longer necessary. This is going to change because if there is an exception, I do want to kind of go through a cleanup process, which is basically going to ideally cancel all of our task. And it should, sorry, I just realized there was a typo. And it should cancel those tasks. It should close the loop and stuff like that. So again, this is a little bit misleading right now. It's not going to just print. It's actually going to do some background stuff, but I'm still working on refining that closing process. So just be patient with that one. And I'm going to put some line breaks in here so it's a little bit easier to read. Okay, so at this point, what have we done? Well, we've defined our receive message. We've defined our send message and all that stuff. We're going to define our last asynchronous function, and then we're going to call it quits for this video. So we're going to do heartbeat, and it's going to be self.connection. Again, I will be seeing if I even need to pass through that connection keyword. Otherwise, what I'll do is I'll say while true, try await connection dot send, and we're going to do ping. And then await, async IO, sleep, and then we'll sleep for 5 seconds. So async IO has a sleep method that will basically pause this asynchronous function for 5 seconds. Otherwise, it's basically this guy again. So if it encounters an error, let me know. Additionally, just so you're aware, you don't technically need to have this function here. There's no requirement. Now, I put it in there because there are some times where requests can be a little bit distant in their response. And so in those situations, I do want you to know that the server is still open. But keep in mind, you don't technically have to have this. I'm surprised it even works technically because I don't know where I call it up here. It just seems to kind of work and there doesn't seem to be a reason for it, but I'm doing a little bit more research on that one. So we'll see. And with that though, I think that is everything. So at this point, if you got any questions, feel free to put them down in the comments below. And just as a little reminder, if somebody again could just check that out for me, that would be really helpful. Again, just see if it works. If it does, can you please copy the data that's printed into your terminal? And then like just email it to me or something like that. If you need my email, it is down here. So it's down here under the support project. So if you need that there, it should be there. But again, if somebody could just try that out, if you have futures or Forex enabled on your account, that would help tremendously. Otherwise, in our next video, we are going to basically build our validation topic. We're going to build our request template, and then we're going to build a simple request and see if our streamer works. So with that being said, we will see you in the next video.